What's going on, y'all? Welcome back to the stream. If this is your first time checking out my content, consider hitting the like button, consider subscribing to this channel. So if you guys remember in the last session we had, the last technical session, we talked about basically designing a TicTacToe interface with React and JavaScript. And so kind of sputtering through, I sort of figured this out. For those that don't know, I'm actually joining a boot camp in the next couple weeks. So in actually interviewing for the boot camp, learning a lot of JavaScript, just kind of through different study modules, probably about 8 weeks worth of studying and different pair programming. I start to have a general understanding of how things work. So I figured I'd share with some folks who might be doing the same thing, whether they're developing for EOS.io or just general app development as well. Just I think helpful to share share the knowledge around and see what others are developing. So that's why I like to do these videos. So what you guys are seeing on the screen is a very basic TicTacToe app interface. I'm using a local host on my port 3000 to run my app, and it's again a very simple app, because the whole point of this is not to sell the TicTacToe app or commercialize it. It's really just to start to build up different skills that I'm going to need to design other applications and start to understand the different tooling and methods that are available within, say, React, JavaScript, the DOM within HTML. Those types of things are integral to app development. So I have a div which just contains my title for my game, which is TicTacToe. I have another major div here that takes up a big portion of the screen, and that's for the TicTacToe interface. So obviously TicTacToe is made up of 9 different boxes, and I think everybody understands how TicTacToe works, but for those that don't, essentially the target or the goal, if you will, is to have 3 consecutive marks of your type, either an O or an X, across, diagonally, or down the line to win the game ahead of your opponent. So because I'm designing this to start with as a single user game, I had to actually design a bot, which seems maybe simple, but it actually turned out to be more work than I actually would have imagined. So I'll kind of take you guys through that in a moment. And then on the bottom section here, we just have the prompt to the user. So this tells the user what to do. In this case, it's just your turn, opponent's turn, and it also should talk about who the winner is, or if the game's basically over. So very simple interface. Didn't want to get too crazy. In an actual commercial game, what I would imagine we would do, or in a commercial say transaction, there would be some kind of an input for the user to connect with another specific user. Because this is a TicTacToe game, I'd actually imagine that to be a more randomized process, where you have a queue of interested players basically every game, and you connect the two, create a session, maybe store that in a EOS.io table, data table, to log in the users. And we actually already created that in the last session, if you guys remember. I won't really be doing that in this one, because my particular interest is not going more full-blown into TicTacToe games or NFTs or anything like that. I have kind of a different goal in mind, but nonetheless, yeah, that's very basic interface here. So the game starts out by actually flipping kind of a coin using the JavaScript math.random method. And so what math.random does is it takes a number, it takes an input, and it provides you an output between 0 to 1, and you can scale that, and through using other methods such as ceiling or floors, you can actually basically simulate almost like a coin flip. So that's what I did, guys. I was a little curious how other EOS.io projects actually achieve quote-unquote true randomness on the blockchain, because I wouldn't consider JavaScript's math.random method truly random. Although for the purposes of what I'm doing for this particular demo, I think it's just fine for what I'm trying to do, which is a very basic React application. So the prompt you see on the bottom there will change. If I refresh this page, for example, we may get another person that starts the game. So you can see in this case, it started with the opponent, which is the bot I built. And the bot has an X. It's using the X symbol. So I'm going to use the O symbol as the player. It's now my turn. So the bot chose the middle position within TicTacToe. So if I choose, for example, the first position, the bot actually chose the top. So you can see they're almost going to win here. I'll go ahead and press the button here. So as you press the boxes, it basically creates a onChange event. The onChange event fires off a function that essentially updates the state of the game. So I have a state to keep track of my game board, all the different pieces, and I have a set of actions for the bot, the user, different aspects of the game. So if I click on this, for example, you can see the bot again chose this time to go on position 3. It looks like they're trying to get to this last position. So I'll try to shut them down here. We'll select last position. You can see that now the bot's trying to go vertical to win. So I'm gonna select that one. And finally the bot chose the last one. So you can see in this case, we ended up with a draw, which isn't too bad. Again, the whole intention of the bot is to simulate a real user. So I think I did pretty well with the bot. The bot's made up of several basic components of TicTacToe, the principles of TicTacToe. So first of all, looking for a consecutive 2 of 3 series of X's, right, would tell the bot that it has an opportunity to win the game. So when it sees that, it's going to select the third position to win the game. If it doesn't see any opportunities to win the game, in order of priority, the next step or the next priority for the bot is to actually determine if the other user is in a position to win the game. And so it looks for my pieces, and it looks of a 2 of 3. And if it sees a 2 of 3, it's going to try to defend that. So I'll show you guys that example. So in this case, I'm going to start the game off. And so if I start the game off, let's just use the bottom left piece here. You could see the bot chose the middle again. And so if I choose this second position, the bot should actually recognize that and choose this bottom right position to stop me from winning. And you could see that right there. So the bot is doing what it should do, kind of acting like a human would in this case. And if I do something here, it actually should, so if I choose, I know normally we would choose the left corner, the left top corner to stop the bot from winning. But if I choose the right one, the bot should, like it did, see the opportunity to win the game and select that position. So you can see that when there's a winner, it actually flashes yellow, and the message should be computer wins. I have to update the message prompt for that in my React app, but that's a simple update. So again, just a very basic app, shows you kind of a working concept. Next steps for me are really to combine what I've learned in EOS.io smart contracts and React apps and sort of combine them together to make a very crude demo of an actual application. It won't be TicTacToe, and it probably won't be games. It'll probably be something a little bit more applicable, I think, for solving a problem. That'll just give me motivation, but I did want to just get my hands dirty on doing a game. I'm also going to be pretty busy with the boot camp, so it might take a while to see my next update, because the boot camp will actually be 12-hour days, 6 days a week. So it's a pretty intense boot camp for about a quarter's worth of work, on top of the several months I put into getting this far in my journey in terms of becoming a software, kind of a software developer, former engineer. But this has been my goal. So I'll take you guys through the next steps here. In terms of my coding, and if anybody else had an interest in this, I will upload the crude code into GitHub, and I'll try to post a link into the description following this live stream. Very basic again. It's not meant to tell you this is the way to do it, because it's certainly not. But I don't think you really get an opportunity to learn React, JavaScript, any subject actually, engineering, whatever it is, without actually doing it, getting your hands dirty. That's the way I've learned the best way to do things. And so even if it takes a little bit more time, it's a lot more instructive and beneficial, I think, for newbies and anybody who's interested in doing this, versus monkey see, monkey do. That's not what I want to, I guess, share. What I'm trying to convey is just general concepts and what are some of the things I've learned in my journey thus far. So as you guys know, React leverages states, and it has a couple different methods there to help basically maintain or set states. And states are just states is just the status of different variables or pieces of data in your application. So as the application receives actions from a user or multiple users, the state of the application is going to change. Setting the state using React is a really nice way to keep track of those states, because otherwise the data, where the data is stored and what's being rendered on the screen, basically the model, the view, and the view and the rendering could all be sort of out of sync without React. So React is nice in that way. And it also allows us to do some asynchronous type coding, which is a benefit, because typical JavaScript is basically a thread of execution. It's line by line. But with these enhanced methods that we have available to us, we can set certain actions based on, say, a user's selection within an app. So it's really powerful. So in this game board, I basically created a component within my application called game board. And game board has a couple different constants. I have winner, last move, colors, and React provides the useState method to basically set our initial state for our variables, and also provide, as a return from using the useState, it provides us methods to change the state of those variables. So I'm using what's called, I believe, a deconstructed method here to assign the variable winner, or the constant winner, from the return of this useState. And the second portion that useState returns, I assign that to setWinner, and that's the function that changed the variables. So I have 3 of those, and you'll notice that colors, in this example, line 12, what I did there is I also used the used state, but I used an anonymous function, what's called an anonymous function. And the anonymous function allows us to build some logic in to setting that use state. So I used an anonymous function with no inputs, and what I did is I temporarily filled an array with a certain color, In this case, it was just a darker gray, and I returned that as my initial state of my grid. And so my idea was that as my application evolves and as I get a winner, for example, I would update the sequence of winning tic-tac-toe positions to yellow. So very simple, but just to demonstrate that I understand use state. That's what I thought would be relevant. And then I have a board game, and the job of the board game is to keep track of the state of the board game, the grid. And so the board game also is made up of 9 positions, each filled to null. So they're initially set to null. And those array positions are intended to keep track of the user that's selecting them, either a X or an O or null in this case. So if the position is already set to an X or an O, we wouldn't let another user select that position, obviously. So that's a pretty important portion of the game. The other important portion of the game is to keep track of whose turn it is. And so you'll notice that I have a turn, an actual turn state. And the turn state initially sets the initial value of that to a random math.random function times 2. And I math.floor that returned value. So I get either a 0 or 1. Which is perfect for what we need because we have 2 players, and we want to make it as fair as possible for these users. So I thought that was the best way to do it. Again, I'm kind of curious to hear from the developers within EOS.io what's generally used for simulating true randomness in games. Again, I just used a math.floor from the return of a math.random times 2 to get a random number. I think there's probably some better ways to do that, but fortunately for me, it's not as critical for this application. Okay, and so then the next step is your use effect. And so what a use effect does is it basically responds to any changes within certain components of your app. And those components are part of the use effect definition you apply. So in my case, what I wanted to do is anytime there was a change to my game board, I want to do a couple things. I want to check to see if I had a winner, right? Because that would stop the game. And I also wanted to run the bot if it was the bot's turn. And I also wanted to update the message to the users, right? So the user might tell the user it's their turn, or might say that it's the opponent's turn. I want to encapsulate all this in this use effect. And finally, I wanted to add a couple functions, helper functions within my use effect that would help update the game board in this case, right? Because that's what effectively we want to do. We want to make this app look very fluid as we run this code. So we have a couple helper functions in here. I have a color box, which changes the game board colors with the winner. I have a check for winner, which checks to see for sequences of consecutive X's or O's and determines if there's a winner from the computer or the local user. I have a set of run opponent bots, and what the run opponent function is it allows this code to recommend a move for the computer because it's a local user against a computer. We want the computer to bring some competition, so we have to teach the computer what logic. We have to teach it how to play the game of tic-tac-toe. So we come up with rule sets, right? And we look for patterns in tic-tac-toe to identify what the best recommended next steps are to win the game. We also wanted to simulate a little bit of a random user as part of the bot. So I don't want the bot just to simply return so quickly and from when I did my turn. So what I ended up doing is I used the math.random function, and I put that in a set timeout. So if you guys know about JavaScript, what set timeout allows you to do is it allows you to run a function after a certain time, a delay is called. And you can randomize the delay using a random function. So I use the math.ceil to a math.random, and I'm able to simulate a delay between 1 and 2 seconds for the response of the computer, so that it just seems a little more natural in terms of how the game responds. And finally, we have a function called move, and the function called move is just a helper function that sets the move of the computer. So I do a bunch of checks in terms of its positioning. I do think that in retrospect this probably could have been done in a much more seamless way using maybe a fast cache method with some objects and storing some pattern recognition of what constitutes a winning game, or even an array of arrays with columns and rows, and leveraging that relationship to find winning patterns in the game. But nonetheless, I did go through the permutations of simulating all the various winning combinations thereof to provide the bot, again, provide the user some competition against the bot. And then we have our good old set move handler, which is the more classic maybe thing that a lot of you guys are used to with JavaScript, where you set these handlers to respond to different events with on an interface. So like a button or div in JavaScript, if that area is called on the app, we want the function to do something. So this is our, say, our first line in terms of responding to an action within the app. And so my particular move handler checks to see if whose turn it is and if there's a winner. And if it determines that there's no winner, and if it determines that, for example, the turn is the local user, it starts to respond to the action of the local user. It'll set the board. It uses the set board function, which will update the board, for example, to reflect what position the user's selected, assuming it's an open position. And it'll also update the message, right, to tell the opponent and tell the user that now it's the opponent's turn. So it does a couple things there. I also store the last move. So I store the local user's move into a cache, and I do that to essentially keep track of. It helps the bot make a recommended next move. So we kind of study what move has been done by the user, by the bot, and from the user. And by doing that, the bot can have a better idea of what next move it should do. Not really relevant to development outside this particular application, but nonetheless maybe interesting. And then we just have a very simple return JavaScript execution language with divs, with the title, and with the containers and the grid. And this grid then, this grid container class name and item class name then correspond to my CSS, which is included. And so I just did some very simple cascading style sheet assignments here for colors and grids and whatnot. And so that's very much, it's pretty much it. Once you get all that done, in your return statement for your app.js, you're going to return that component. In this case, my component is called GameBoard. One of the things that a lot of people get tripped up on is the import-export statements. So when you make a new component, it's really important to make sure that you're importing your components into your app.js, and then you're exporting your app out. Super important. And also the imports for your use state and use effect at various positions. So that, I think, summarizes things fairly well. I just thought I'd do a quick update. I didn't want you guys to think that I was just slacking off or anything like that. Definitely making moves. And like I said, the next step for me is a boot camp. So that's what I'm going to be getting into next. Just studying up for that. If you guys have an interest in that, let me know. I'm going over more traditional frameworks of computer science. So like data structures, linked list, tree structures, deep search in the tree versus breadth searches. Those types of things are pretty integral. I was able to solve some problems without those methods, obviously, but certainly not as efficient in the problem-solving domain without a mastery of those methods. So that's going to kind of be my next step, guys, in addition to keeping up with things in EOS. For those that maybe aren't aware, we are trying to organize a hackathon for EOS, and so I would recommend that for anybody who's watching this video who has an interest in that, it is important to show up, because like guys like me, as you guys know, do not get paid for doing it, and I think it's a really important event or opportunity for EOS to provide for the broader developer community, even outside of EOS, outside of blockchain, if we want to see the apps get developed. And so whether you have an interest to participate in the hackathon or not, we could still use a tremendous amount of help, volunteers to help translate, for example, promoting the hackathon, support for, maybe seeking out judges, discussions on how we best promote this event. So it's not obviously been approved yet, and part of the reason is we haven't really received that engagement, I think, from the community to tell us, tell everybody this is something that there is an interest to do or not. I personally am going to develop my applications with or without EOS, so this is not a personal thing. I have my own interest, obviously. As an engineer, I love creating things. But I just think it would be really good for EOS to have something like that, because you can't really have a community of developers if you don't provide the opportunities for people to be aware of what it even is. And right now, I just think the community as a whole has so few developers, and the ones that are capable of developing, in my opinion, it seems like most of the focus is on the core stack of EOS.io as a blockchain, which is incredibly important. And so it's really important to start to cultivate, your app developers to actually build on EOS.io, whether that means traditional C++ or maybe in the future using the EVM capabilities. So anyway, that's a little bit of my rant today. I hope everybody's doing well. And tell me in the comments below, what are some things you're doing? What are you learning? How are you investing in yourself? I made a video probably about 6 weeks ago at this point, telling you guys, I think in my opinion, the best thing that everybody can do at this point is invest in themselves, because where we're going as a society is more global in nature. It also means that software is going to become more dominant in the lives of in our lives every day. APIs, more smart devices and technologies and things linked together. So that's where we're going, and it's important to have that skill set or at leave be aware of it. So leave it with that, guys. I hope you guys enjoyed this video. And I'd also like to know if you guys have any ideas of things you'd like to see built on EOS. I'd like to hear that at this point. We spent a lot of time, obviously, we spent a lot of time on the theoretical, reading, writing, deleting, editing, EOS.io, blockchain, the certification. We spent some time on front end. I think it would be really cool to actually build an application on EOS that is actually useful. And so that's one of my goals right now, is to find where those needs are and build it. Not necessarily tool sets, but actual applications that use some component or some feature for EOS in particular, but even EOS IO if that was an interest. So thanks so much guys for tuning in, and until next time, have yourselves a great day. Peace.